In this video, we're going to talk about operations with matrices. Let's start off with equality of matrices first. Two matrices, A and B, are equal if and only if the matrices have the same order and all their corresponding elements or objects are equal. All right, so we want to determine the values of each variable to make the matrices equal. So, in order for them to equal, the corresponding elements are equal. So we know x is equal to 2 plus y. -4 is equal to -4 is done for us. 7 equal to 7, already done for us. But notice also y is equal to 5. Well, I can substitute that in here, and we can tell very quickly x is 7. So when x is 7 and y is equal to 5, these two matrices are equal. All right, so let's take a look at these two then. Again, we've already got 7 equal to 7 and 0 equal to 0. But we also have 5 equal to x minus y and 10 equal to 2x plus 3y. Now, this is a system of equations, but notice I have not given you a specific way to solve these. So we're going to do the quickest, most efficient way. I'm going to do elimination, and I'm going to multiply the top equation by 3 to eliminate y. So what does that give me when I add the two equations? 25 equal to 5x, and 5 is equal to x. So we can plug 5 in, and we can tell very quickly that 0 is equal to y. So when x is 5 and y is 0, that is when these two matrices are equal. All right, so the next topic then, let's go back to a previous math course, and if I ask you to distribute that -5, what would you do? I would take that -5 and multiply every single term that is inside the parentheses to get this. Okay. And because there's no like terms to combine, I would be done here. Well, scalar multiplication is very similar. We've got a number that is outside the matrix, so I'm going to multiply every single element in that matrix by that scalar. So when I do that, I get this here. All right. So now that we've talked about scalar multiplication, matrix addition and subtraction also very similar. In order to add or subtract matrices, the matrices must have the same order. Add or subtract each corresponding element. Okay. So for adding these 2 by 2 matrices, again, very simple to do. I'll show the step once. And then I can simplify. Notice your final answer is also a 2 by 2 matrix. Dimensions does not change. Okay, so subtraction is very similar. Again, I'll show the subtraction step once. And again, notice it's the same dimensions. Now, keep in mind with subtraction, you could have always distributed a -1 and put addition in between also. That's fine, because a minus b is the same thing as a plus a -b. Okay, so now let's get a little bit more involved with this. Now, let's go to the recall example. Well, back in a pre-algebra course, what would you do? You would distribute first, or multiply. Then I would combine like terms, right? I have those here, and I would be done here. Well, matrices is going to be very simple. We'll multiply by the scalar first, and then add or subtract matrices. So let's multiply by the scalars first. add the corresponding elements. And we're done here. All right, so now let's do the subtraction here. But again, I'm going to multiply by the scalars first. Now here, I'm going to multiply by a -2 and put a plus in between. All right, so now add. And again, notice for both of these, we still have a final answer of a 2x2 matrix. All right, so the only other thing on this page is what is called the zero matrix. That is a matrix which every entry is 0. So I've listed below the 2x2 zero matrix and the 3x3 zero matrix. Now, we do know that 3 and -3 are additive inverses. Now, why is that the case? Well, when I add these two numbers together, I get 0. Now remember, 0 is the additive identity for that, meaning that I take any element and add 0, I get that element. Well, we could determine an additive inverse for a matrix very, very simple. I can do C plus the opposite of C is equal to 0. Now, in this example, I've already given you what C is. And remember what we want. We want the zero matrix at the end. So what am I going to do? I'm going to take the additive inverse for each element that is in matrix C. So that's easy to determine. Okay, so that'd be -2 and 1 and -4 for the first row, and -5, 6, and 3 for the second row. So this matrix is the additive inverse to C. And again, easy to check. When I add the two matrices together, I should get the zero matrix.